Hello, everyone. Good afternoon, and welcome to the FIWARE Water Day. It's 2 now, and we've got a jam-packed agenda, so I'm just gonna start right on time. My name is Charlotte Kotterman. I am the community manager at FIWARE Foundation, and I would like to thank you all for joining us today. Before I jump into the introduction, I would just very briefly like to go over a few things. We ask for all attendees to mute themselves and to turn their cameras off throughout the presentation to avoid any connectivity issues. Secondly, this is a live event and it will be recorded. So by attending this event, you agree to the recording, which will be made available on the FIWARE YouTube channel. And lastly, this event will include 2 Q&A sessions. So we please ask you to drop any questions you have throughout the event into the chat or to simply ask them during the sessions. So for those of you who are not familiar with us, FIWARE Foundation is a nonprofit organization that drives the definition and encourages the adoption of open standards implemented using open source technologies and reference architectures to ease the development of smart digital solutions across multiple domains, including the one we will be discussing today. Now, water is one of our most precious natural resources, and it is a key element for global well-being and sustainable growth. But we still face challenges. The efficient and sustainable management of water distribution systems is not an easy task, and we want to ensure, if we want to ensure safe and reliable fresh water supply to consumers while maintaining efficiency at a low cost, something which is fundamental in almost all industries, that can be quite a challenge. So nowadays we are already using a wide range of advanced tools and strategies to address these pressing challenges. And these include water quality simulations and the modeling of water distribution systems. But the water domain has not yet reached what some may say a satisfying level of maturity when tackling digitization challenges such as fragmentation, lack of a holistic vision, or integration and standardization of the technology. So throughout this event, we will analyze how to overcome these challenges from different perspectives and how we can do more with less water in a sustainable manner in order to make an effective change. So once again, a very warm welcome to today's FIWARE Water Day. Now please join me in welcoming our incredible speaker lineup, including E.G. Nadhan from Red Hat, Robert Brears from Our Future City, Professor Dragan Savic from KWR Water Research Institute, Frédéric Charles from Suez Smart Solutions, Kate Baker and Chris Sweetapple from University of Exeter, Ben Ward from Southwest Water, Dr. Yoon-Suk Yuna Kim from UDG Alliance, Dr. Anastasios Karakostas from Center for Research and Technology Hellas, Adriano Mancini from Marche Polytechnic University, Arjen Hof from Civic, and last but not least, FIWARE Foundation's Ulrich Ahle, Juan Joyero, Cristina Brandstetter, Alberto Avella, and Fernando Lopez. So in addition to our speakers, I also want to take this opportunity to thank our collaborators, Robert Brears and Our Future Water, as well as our media partners, Business Reporter, Compass List, EU Observer, Zoom Global Cities, for their incredible support in disseminating this event. And now I would like to introduce you all to the person who will be guiding you through today's virtual event, namely E.G. Nadhan. Nadhan is the Chief Architect and Strategist for North America at Red Hat. He provides thought leadership on various concepts, including cloud, blockchain, analytics, and IoT through multiple channels. With over 25 years of experience in the IT industry, selling, delivering, and managing enterprise solutions for global corporations, Nadhan engages in strategic dialogue with IT decision makers and influencers across the ecosystem of customers and partners in North America to drive outcome-based differentiation with the purposeful application of technologies. So we're very excited to have him with us today, and without further ado, I will now hand over the mic to Nadhan.
Thank you very much, Charlotte. It is my honor and privilege to be here with this distinguished lineup of speakers. I look forward to learning from everyone. And what you said about the application of technology is really what resonated with me. So let me start sharing my screen here. So just briefly about Red Hat. we are all about collaboration, and when we work with organizations like FIWARE that we are a platinum member of, we do this because of our presence in the open source community and how we actually encourage and then advocate and be a catalyst for the open source projects that we advocate, and then we integrate them and stabilize them and bring that into the Red Hat platform. And we have not only worked this across multiple industries, but when it comes to utilities, there are cases where customers have actually adopted, used it for water and kiosks, as you are seeing in this scenario where Brears actually had the water and sewage utility services. That's what they provide. And to centralize the management of its network of smart kiosks and dispensers, they are using open source technologies and open standards for microservices-based architecture. So that's really, there is a lot that we can do. Water is universal, and there is, I cannot think of a better channel to collaborate globally for the betterment of everyone concerned. All right, so with that, let me introduce our first speaker, Robert Brears. So Robert is the founder of our Future Water and author of Urban Water Security, the Green Economy, and the Water Energy Food Nexus. I cannot think of anyone better to kick us off with his thoughts around the need to digitalize water. Robert, please take it away.
Thank you for the very kind introduction, and good afternoon, everyone. So today I'll be speaking about the global overview, the need to digitalize water, and I'll just spend a few moments just more looking at the broader concepts of where we're heading and what we need to do, rather than the technical side of everything. So first of all, some of you may be very aware or learning about water or at very advanced stages of water. So I'd just like to run through the mega trends that are impacting water resources that we currently face as we move through the century. So we know that urban, massive mega trends are impacting the water quantity and water quality. We know that climate change is increasing the frequency and magnitude of both floods and droughts. We also know that floods contaminate water supplies, while droughts increase the pollutants in waterways, increasing the cost of treatment. We also know that rapid urbanization is increasing demand for water from households and businesses, industry, energy and food, etc. We're also very aware that aging infrastructure is wasting water, adding to water scarcity and pollution. In some cities, we could be losing up to 20% of our water supplies just from leaking pipes alone. We also know that increased water demand and water pollution is causing biodiversity loss. You only need to see the latest WWF Planet Index or the latest UN report the other day. 84% of freshwater aquatic species are under threat or going extinct pretty much because of our human behavior towards water. So a business as usual approach would be saying that we're going to be facing more scarcity, more competition, and even possibly conflict over scarce water resources as the century progresses. So the first concept that I'd just like to talk about today is future of water management based from the actual demand management side. And by, we're trying to look at how do we, we see this world that we've got, but we can actually change the future. It's not set in stone. And one of the things that we can look at is what's called demand management. And traditional water management relies on, large-scale supply-side infrastructural projects to meet rising demand for water. This approach is very traditional and it's very economically expensive as well as environmentally costly. In contrast, future water management, we should be looking at what's called demand management. We're actually, changing our attitudes and behavior towards water resources. So instead of, running out of water and deciding to, develop a new water supply, we turn inwards and we start thinking about how to conserve water in households and in our businesses and using our water that we currently have the most efficiently as possible. And by doing so, we have huge numbers of benefits. If we focus on demand management, we've got more water for a healthy environment. We've got reduced water leakage in the water distribution networks. We've got lower carbon emissions from having to treat less water, and also just a more environmentally conscious, aware society. And you're probably wondering, well, how is digitalization fitting into this concept of demand management? Well, we have smart meters for businesses and households. We have AI and leak detection and water distribution systems. And we have auto leak detection for households. So there's many opportunities for technology to fit into what's really seen as changing attitudes and behavior. So this is the social sciences coming together with technology to change the way that we perceive water, and we focusing on reducing that demand that we have, because the water is scarce, and we're moving to a century whereby we see the stats all the time that by 2030, by 2050, 2060, 2100 even, we're running out of water. But actually we have enough water on Earth. It's just the way it's distributed at the moment. So we need to find a way of being more efficient in our water resources. And also like to talk about the future of water management from what's called the green infrastructure. And this is about managing too much water this time. With traditional stormwater systems, remove runoff from buildings and houses and driveways, etc. And this is a very traditional, every city has it, combined sewers, it takes out the rainwater, it flushes out to sea even. However, this traditional approach has meant there's less groundwater recharge, has resulted in less water for biodiversity. It actually increases downstream flooding risks. It also increases pollutants entering the waterways with combined sewage overflows. So in contrast, future water management should be using green infrastructure, which is the use of natural and semi-natural processes to cleanse water, to manage too much water, and also to store water for future times of droughts or scarcity. And the best thing about green infrastructure, instead of traditional grey infrastructure, is that it provides multiple benefits. It has education benefits, it has biodiversity benefits, it has urban heat island effect reductions, it reduces energy costs, etc. So by moving towards this way, we can actually be more harmonious with the earth and the way we manage our cities and how we manage agricultural production with nature-based solutions more. But you're probably wondering, what has digitalization got to do with green infrastructure? And we say that, okay, green infrastructure, it comes in many shapes and sizes, includes green roofs, green streets, urban parks that store excess water. And it's just like the question is, how can it be digitalized? That's the point of today. But actually, there's many opportunities to digitalize green infrastructure. And we're already seeing technology monitoring their performance. So how is it actually, is the green street really improving water quality? And is it really reducing pollutants in the air? And also with green roofs, is it really reducing the energy consumption in the building to heat or cool? Also, green infrastructure can be digitalized to inform society. So this technology apps and data can all be sent to smartphones, so people can actually see, neighborhood, the temperature on the day itself, which neighborhood is cooler on a hot day, and what are the air quality improvements being made by green infrastructure in cities. And and also green infrastructure, this technology can also be used to facilitate urban planning. And I've got here, I mentioned about mapping of cities to show potential for green infrastructure. And what I find really interesting is that you've got cities like Berlin, which have mapped, rooftops to see the potential for green roofs. That helps urban planners think about the future and realizing, wow, that only 20% of green, the city has potential for green roofs, or only 20% of the city actually has green roofs. And that can actually be used as a tool to influence political decision makers, urban planners to think, well, I want to actually contribute to a better future for my city too. So while I talk about these mega trends and the challenges that we face, I also like to show that there's a bright future that awaits us if we manage if we manage our water scarcity effectively, and if we manage our water excess water well. We can actually have a really bright future that takes into account climate change, and we can reverse the environmental degradation of urbanization. We can become more resilient, and we can even create green jobs and a low carbon economy from that. And the future is bright with digitalization. So digitalization can help communities become more water wise by raising awareness. It can help industries reduce water footprints and minimize environmental degradation. And it can help reduce operational and maintenance costs, energy use and carbon emissions, and drinking and wastewater treatment. And also digitalization can ensure that a green infrastructure operates efficiently and benefits both humans and nature. So on that note, that's my last slide. 1 second. Yes, so thank you all, and I look forward to questions, and also please ask away if you want the slides. Please just email the FIWARE and I'll be happy to pass it on. Thank you very much.
Excellent, Robert. The future is bright. What a way to start this session. And I can see the sessions today are going to be bright as well. So fantastic. And Robert mentioned about the many opportunities for digitalization. So what does that mean? What are some of the trends that we are seeing in digitalization? That's what we are going to learn from Professor Dragan Savic, CEO of KWR Water Research Institute. Please take it away, Professor Savic.
Thank you for the invitation and for this introduction. I will just give a general introduction to the digitalization of the water sector and general trends. First of all, KWR is an independent water research institute. It's publicly owned by Dutch water utilities and one Flemish. We've got about 180 employees and 135 researchers covering the full water cycle, and we're based in the Netherlands, in Nieuwegein. So the idea is that we cover the entire water cycle, and we want to generate knowledge that brings the management to water-wise management. And also we are focusing on the United Nations Sustainable Development Goals, and you are probably all aware that the way or the rate of meeting these goals, or the data shows that we are not going to meet this particular SDG 6, which is related to water and sanitation. So some work still left to do for us. Basically, the way we see those development goals is that the water is in the middle of it, and that everything else is related to it. And the COVID situation reminded us very much what sanitation means, and good sanitation means to health of the population and how important it is. So if you look into digital water, or smart water, or water 4.0, as people call it, basically it combines the value of water with the value of measurement and data and knowledge that we can gain from the measurement. So all of this will lead to smarter, I would say, water management than we are doing today, but also links into the trends of the society, where we are developing smart homes and smart cities, inclusive and informed citizens of our cities. So the tools used in this process are of digitalization and integration of data, integration of processes, There is quite a lot of data already, but the problem is that there is less of that integration. And when we are talking about smart cities, quite often you hear about smart energy, about smart internet, about Wi-Fi and everything. The water is kind of hidden there. Then digital business models, you know, quite a lot of is happening also in the water sector, and new business models are being developed where new companies and new partnerships are formed to exploit the data obtained through these systems, and also customer access and engagement. Again, the knowledge of the general public of the processes their water goes through until it comes through their taps at their homes, and then it's flushed down the toilet, often are unknown to the public or less known than anything else. We all understand that electricity has to be generated and paid for, but water is something different in people's minds. So that's one of the kind of obstacles, education of the public, and also products and services that come with this digitalization. So what are the challenges? The challenges are quite often that you can see a very complex cycle here on the right-hand side, water supply. Then we have the sanitation part, groundwater, surface water. I mean, lots of kind of complexity there. The digital water should and must include the whole water cycle. And that's against kind of the general trends in the water industry, which is traditionally conservative. And that's understandable because they produce or provide service that is related directly to the health of their users and customers. And it's also the industry that is fragmented. Fragmented even within the single organization. So quite often within an organization or water utility, you will find out that they have a leakage department, wastewater department, asset management department, customer. So the data is also fragmented. So information science and data science, data analytics, digital technologies are relatively recent additions to the water sector, but rapidly increasing, becoming a new digital reality because everybody realizes that the rest of the world is moving in that direction. So is the water industry. So the sector is in the digital transition process. So this just shows how the digitalization of the water sector is related to EU initiatives. In 2011, the EU started funding or opened the call for funding, and first 5 projects you can see in the graph on the right. First 5 projects started, and next year they had another 10 and another 10 in 2015. So that all led to the need to be organized, all these projects and activities, and that's the ICT for Water cluster that creates synergies among these. And so you can see on the left different organizations, professional and trade organizations, different conferences, all sorts of kind of synergies and integration across the sector. They're all involved one way or another. So ICT Water is that cluster that is contributing to European Commission strategic views and creating synergies. So they created in December of 2018 the final version of the Digital Water Action Plan, targeting a digital single market for water across Europe. And it's showing what is needed and how can we get to that along that plan until 2023 in the domain of digital water. It has 7 action groups. And those action groups are, you can see here, the people from various projects and outside these projects of interest could join these action groups, but you can see it's quite wide-ranging from standardization to business models. And that brings me to today's meeting, and also to the 5 projects that have started relatively recently. There was a call in 2018 looking for digital solution for water, linking the physical and the digital world for water solutions. And you can see 5 of those projects that are now kind of united under the umbrella of the Synergy Group, which are part of ICT for Water. And the common component of all of these is FIWARE. FIWARE is going to be investigated, or the ways of creating compatible applications through on FIWARE, those applications for the water sector. So that's where today's meeting or the webinar is all about, to inform everybody, to look for new synergies and what can we learn from each other. So the last slide is about what is the future, what is happening, what are the trends and challenges. So European data space, looking for a single European data space with single market for data, open data from across the world. And I would also mention here that people often just focus on the data coming from the water sector, but we need to leverage much wider data in the population. IoT is important for that. Then artificial intelligence, the EU is investing quite a lot, and something that will improve the lives of people and respecting their rights. And you know, in that case, we should also look into ethics and privacy of using private data. And finally, the latest one is the Green Deal strategy, in which Europe is going to put huge funds. So the full benefits of the digital transformation need to support this ecological transition. So that transition to more green, but I would also say green and blue Europe. So with that, I thank you for your attention, and I would be more than happy to answer any questions if there are. Thank you.
Thank you, Professor Savic. So Robert started saying, you know, the future is bright, and this is the perfect segue. You walked us through the trends from a water management perspective and opened up the dialogue for, you know, artificial intelligence. You ended with digital transformation and so on. So thank you very much, Professor Savic. We will get to the Q&A session later. That is a perfect, you know, setup for Frédéric Charles to talk about, you know, how can, you know, cloud platforms enable, how can intelligent water networks, why is it a core for digital transformation? So consider this to be the transition from the business of water management to the technology. With that, I'm glad to introduce Frédéric Charles, the director. Let me try my French. Directeur Stratégie digitale chez Suez Smart Solutions. Go ahead, Monsieur Charles.
Yes, this is correct. Do you hear me?
Yes.
Yeah, okay. So I'm the director for digital strategy and innovation at Suez Smart Solutions. I worked 25 years around IT and strategy for utilities, and more recently in several ambitious smart city projects. So I want to share this perspective on both subjects. Just a short introduction. So Suez Smart Solutions is the digital entity within the Suez Environmental Services BU. It is dedicated to the development and marketing of digital services. So everything we do is digital. It has to do with solutions, leveraging sensors, data platform, AI expert system, and so on. These solutions are used by our internal customers, the Suez Group, but also are sold externally to any company that wants to use this technology. So the two key applications where we are very well known. The one in Europe is that we are leader in smart metering with more than 4 million water remote readings, smart meters. So, and with all that data, that billions of data that we gather every week, we develop smart water management softwares that helps to manage the network for the utilities, and I will be back on that point. So today I want to share with you our involvement in 2 European projects that are contributing to the water utility digital transformation, and emphasize the role of the FIWARE platform to accelerate this project. More broadly, and it has been said by Dragan Savic before, more broadly, it shows the role of data platforms and how this data platform can help to reinvent the utilities information system and lead the digital transformation. Because without that new information system, it's sorry to say that the utility will be stuck where they are today. So I noticed also in the Dragan Savic presentation that the industry is poised to radical changes, but I really like the fact that the industry lack of integration, and the key issues of my presentation is with integration. So the three risks we see in the industry are disruption, technology innovation, and talent. The first one is not new. I mean, telcos in the 90s had plans to manage all the home services from a single box, of course, the telco box. But as you know, this plan failed, and we all know the story of the GAFAs and their focus on the user relationships. And today, some of you maybe have the Nest Google appliance, and whatever is the utility delivering the gas behind, when you think about managing it in your home and managing energy, you are using the Nest appliance and the Nest platform. So the first risk is really is really being disrupted. What is new is that it will be disrupted by the one that knows how to manage the user experience, everything that is social, mobile, and cloud platform, and make the links with the data. But then the utility they have to better manage their operation, because their real competitive advantage is in the operations, and the operations is not, I mean, if you are very good in operation, in the performance, it's not very easy to replicate it when you are a new entrant, a new startup. So this is why they really need to manage, they really need to use innovation to improve their operation and their operational performance. Finally, they also need the digital talents and change the mindset to be able to reach that two goals. So these are the risks. What is the current mindset? The current mindset of the utility is that it is based on 3 pillars: the customers and what we call the CIS, customer information systems. The GIS, managing the asset management, I mean the pipes, not necessarily the plants and so on, and the work and asset management system, the one. But what is new in it? What is new is that each of these systems is now challenged by a data explosion. So let's consider that the customers, we used to have 1 index per year. Now we have 20-30 data per day with smart metering, and with that data per day we can understand the consumptions, we can understand the usage, and we can, for example, predict where tourist attendance are in the cities, for example, just by analyzing this data. In the assets, we are moving from a 2D maps, sometimes most of them in GIS, with several weeks to update them. we are moving to 3D digital twins that are allowing virtual visit of sewer assets, for example, where you can take measure, you are virtually into the asset, you can take measure and prepare your next work into the asset without leaving your screen and without leaving your work remote office. And finally, maybe the biggest revolution is the network management. You're moving from offline hydraulic models that were used to online monitoring of pressure, of water quality, and as in many industries, the long-term goal here is autopilot. It's autopilot the network. This is really the idea. So the new paradigm is the link between these three domains, and it can be done with a data platforms. With the data platform is now seen as the core of the utility information system. So you don't think of silos. You merge all of the information into the same digital twin. Also, we have assets can be really represented with data, and for the network, it enables a smarter networks. So the data platform is the common point of all of the domain, and now it's a basics to develop new services. So what's the link between this transformation and FIWARE? The answer has been said before. It's the lack of integrations, it's interconnecting and interoperability. Interconnecting means flow of data, but it means also open source, meaning sharing of standards, having context data management. And we'll see that this kind of solutions, it's not the only solution on the market, but this kind of solution are also used in smart cities and we'll be back on that. So this is exactly what we have done. In two projects where we are involved, Aqua3S, where the pilot is SCPG in near Paris, and Cicacil in Cannes. The FIWARE is used as a platform for interoperability, an interconnection of the different systems. I have an example on one of these two projects. Today, most of the time, you have a drinking network, you have sensors, you have a SCADA, and you have intelligent systems that deliver three things. First, they start to monitor. Of course, the SCADA helps to monitor, but with that kind of solution, you can monitor for long term. Then the second value is to start to do some predictive, because you have the ability to do some machine learning by monitoring the system, and then to do some predictive. And the third one is the buzz around the autopilot. It's the advanced control and the optimization engine 24/7 hours. But in that, if you add new sensors, like this is what we have done with FIWARE for water, then today with the technology, you can directly put this data into the FIWARE for water platform. You can interconnect it with the expert system, and you can tap into the FIWARE for water platforms on new data science model that has been developed. One for forecast water resource availability or demand management and so on. So the idea is much more in the same philosophy of the open source, but it's much more open code. The idea is to bring into your utility all the value, all the knowledge that is already there and that we can share. And because for sure there are physical rules that make that most of the networks everywhere in the world are working the same way. So what we are doing is that we are moving from the SCADA paradigm, where the only way to move was to use the SCADA and maybe to have expert system like the Aqua Advanced Water Networks. We are moving to a new paradigm where you have a kind of intelligent data architecture, where you can develop new models and then plug the expert system. So this is the way we use it in one of our project. So if we look at the perspective, we have exactly the same problem in smart cities, and it has been said before. You need to, in smart cities, you have different competencies for managing the roads, the gas, electricity, the water, electric light, and so on. So, and you have also to tap into an ecosystem of startups that have a lot of innovations, a lot of new algorithms and new ideas on everything. So then the data, again, could be used to improve the operation of the city, to change the silos and so on. So you have flow of data. This is what we have done with partners in Dijon, which is one of the command center in France that is already operational since now 18 months. FIWARE is also used for that, if you check in the literature for that. But the final point is that if you can see the digital water utility, you can see it as a way also to plug into the smart city platform. So the point is that the utilities, they have to become digital because they have to increase their performance, and this is the way for the future. But they're also living in an environment where everything will have to connect, and this is the message of the smart city platform. I don't know if you have a question relating this, and I hope I open some new mindset regarding the fact that data is really key in utilities for integration, whatever the different functions of the different systems.
Thank you very much, Frédéric. Insightful. You walked us through how technology can be applied for water management, especially next generation technology. So thank you very much for that. We will now move on to the CTO for FIWARE Foundation, Juanjo Hierro, and Alberto Abella, the data modeling expert. So let us now hear from FIWARE on what's the value proposition? How can integration and standardization of ICT solution and smart data models benefit the water domain? I go back to a common thread that I heard from Professor Savic and Frédéric about integration being a challenge. And so I really like the fact that you're going to hear from both Alberto and Juanjo on how FIWARE can help here. So please take it away.
Thank you for the kind introduction. Yeah, we hope we will be able to answer this question. Well, FIWARE is gradually becoming the open source platform of choice when building smart solutions in multiple sectors. And I'm proud to say that water management is actually becoming one of the domains where FIWARE technology is gaining more traction besides smart cities. I'm confident, and at the end of this day, this will not be just a statement on my side, but also a real feeling you all will share. When we talk about smart solutions powered by FIWARE, we always have to think on a common pattern, which is that of maintaining a digital twin representation of context, what's going on that is relevant for the particular solution, the particular challenge we want to solve. And this digital twin representation is kept constantly up to date based on the integration of information coming from many different sources and continuously being processed in order to support the further automation of processes or bring support to smart decisions for water management. Those are actions that may also affect the real world, and this way creating kind of a continuous feedback loop, which is the basic architectural pattern of any smart solution powered by FIWARE, including those for smart water. Information, and this is very important, that is not just IoT data, information coming from many different sources, like information systems, for instance, weather forecast services, third-party systems, everything that may help to create a rather complete digital twin representation of the context. But what do we mean, or we are referring to as digital twin, going more in detail? We refer to this as a digital representation of a real-world asset, something that is characterized by attributes, attributes which might be properties, relationships, and those values of properties and attributes may change over time. Typically, those assets have a location identified, and the overall context, which is information we are managed, is nothing else that the collection of the state of all those digital twins. And in order to create solutions that are based on this digital twin concept, what FIWARE is bringing is to start with the two major key elements. On one side, a standard API for getting access to digital twin data, this description of the context, and in addition to that, common data models associated to digital twin classes that may help us and will be crucial to create the kind of applications that may interoperate each other and be replicated from one particular space to another. In the area of APIs, those that you are familiar with FIWARE, but for those that are kind of newcomers, we are bringing a standard API. Many people are talking about digital twins today as a kind of a buzzword, very mostly commonly used. But if I'm a developer, how can I create an application based on this digital twin concept? What is the kind of API I can use to develop my applications? And here FIWARE brings a first answer. NGSI being the API created first in the community, that was NGSI version 2, now standardized under the umbrella of the ETSI organization and bringing support to creation of solutions. Then the next aspect is data, but here Alberto is going to talk a bit about that. Mm-hmm.
Okay, thank you very much. So we were talking about the integration is an issue for water data management. That's true. And what we can now is to create a digital representation of the assets that we have into the management. Here you can see some elements of the infrastructure, but there are many others. And what you see there is some of the properties that we can define, and in fact, there are much more. So, what do we get with this? What we get with this is just the possibility to integrate, as Juanjo has explained before, because we are sharing an API and we are sharing some elements of the data models. So if we go for the next slide. So we have an initiative named Smart Data Models that you can reach at GitHub, github.com/smartdatamodels, that you can see on the screen, in which we are providing these data models available for everybody under an open license. It's a collaborative effort with some other entities, TM Forum and many other organizations from the water sector. And what we do is just, instead of defining brand new data models, what we do is just to translate existing regulations or real use cases into some data models that can be used across many other use cases. We keep for the generalization, making these data models consistent and allowing the reuse with an open license. And we have an structure which is decentralized, and therefore many people can collaborate simultaneously on creating that data models. And last point is that you can reach the repository in GitHub, but we have also a front end for those users who are not that familiar with technical stuff, and we provide some databases for providing information about the data models in order to be searchable. We provide a subscription with support to the users and to provide some kind of training on the creation of data models. And we have also a contribution manual explaining how to meet the guidelines in order to make these data models compatible with all the rest of the data models, which are not only for the water domain, but for some other domains, because few times, a project is purely of one sector. What I mean, Juanjo told previously, so it's likely that the water will impact on our water management or demand of the city or whatever. And we are able to provide data models on all these topics.
Okay, thank you very much. So again, and to emphasize, an API data models are the very basics for creating portable, replicable solutions, and this is something FIWARE is bringing. And to the extent that we are receiving a quite relevant endorsement at global level, not only by ETSI, but also organizations like GSMA, like TM Forum are backing this approach that we were taking. The European Commission through the Connecting Europe Facility program are supporting the adoption of context broker technology and this definition of data models as the mean for the way organizations may share data and create data value chains across member states. And through this, we will be covering, and FIWARE is bringing standards that help organizations to really support their digital transformation journey. First, breaking information silos within the all map of information systems within the water management company, but bringing also the opportunity, as we have seen, to collaborate with others in creating definition of models that will help to replicate solutions and make solutions interoperate. Last but not least, also bringing components that will support open innovation, the ability to share data and enable third parties to create nice services based on that. And in the future, looking in the longer term to support all aspects of the data economy, and there is a huge potential regarding how data might be monetized also in the water sector. For all these steps in the transformation journey, FIWARE is bringing technologies that can all together mix into a reference architecture for the platform with this major chapter you see here. Chapters bringing components that help to interface with the different information sources that create this digital twin representation. The core element in the middle, context broker, being able to manage this digital twin representation, components on top to be able to process this, and last but not least, components able to maintain all the security and access control aspects that you need to deal with when getting access to information, managing that information, privacy aspects, and all that. This leading to architectures like this. Of course, we cannot go and elaborate on this detail, but I want to take advantage to tell you that to mention to you and give you as a reference the technical webinars we are running every Wednesday, and you can visit our website to take a look at the different sessions, and why not connect and check out some of the sessions where we have described this architecture in much more detail. Last but not least,
we just have a minute or two. Go ahead.
Yeah, finishing. So two final slides to comment. So this technology is becoming really fundamentally materializing the notion of data spaces for the integration at multiple levels, integration within one application, within one organization, but also enabling the exchange between the water operators and other organizations like the cities, like different kind of companies with which exchange of data might be relevant. What comes next, and this is a final slide, also to bring you some insights on activities we are running through which we are developing the technology roadmap of FIWARE. First of all, we of course will be keeping developing the definition of data models. This is, something that will never end. We are going to start and keep going on defining new data models based on implementation experience and being fueled by and fed by the different projects that are using FIWARE. Integration with blockchain distributed ledger technology is a quite interesting space. Is taking quite a momentum in smart cities, but we see this also promising emerging in areas like energy and water management. Those aspects connected to the how to integrate artificial intelligence services, machine learning services in Powered by FIWARE architecture, how to enable a plug-and-play approach for integrating those AI services, which might be developed by people really expert in the field, and is something you could leverage on to enrich the architecture of your solution. And last but not least, and somehow related with the previous slide, all the components that will be bringing support to the creation of data space for data sharing in the water sector. That is all. Thank you, and sorry for the synchronization. We had a little bit in the middle of the presentation, but I hope has been complete enough, and we are happy to answer any questions you may have. Thank you.
Thank you very much, Juan and Alberto. We now move on to the next session, which is about EPANET, EPANET to FIWARE. This would be the first of multiple speakers we have from the University of Exeter, and so Dr. Chris Sweetapple, the research fellow in the Center for Water Systems at University of Exeter, is joining us, along with Fernando Lopez from FIWARE Cloud and Platform. He's a senior expert on cloud and platform from FIWARE. So we are going to be hearing from both of them on linking EPANET to FIWARE. I would say please take 10 minutes, and we would still be okay. So please go ahead, Dr. Sweetapple and Fernando.
Okay, thank you very much. My name is Fernando Lopez, and together with Chris, we try to provide some overview about this activity inside the different European projects in which we are collaborating. I started with a brief description of what is EPANET. EPANET is an open source solution application for modeling water distribution systems that is mainly used in the research and industry, helps to provide extent period simulation of hydraulic and water quality behavior. Also, this solution, this application allows the modeling of contamination and evaluation of resilience to security threats or natural disasters. And last but not least, include a graphic user interface and open source toolkit in order to work with it. Why we wanted to link this EPANET tool with the FIWARE ecosystem? Because we planned to facilitate the real-time modeling and operational management of those simulations during this tool, using these tools. We wanted to aid the integration with other data sources, mainly regarding any other kind of IoT, AMI meters, legacy data access, SCADA system, geographical information system, weather information, and so on and so forth, with the purpose to create a dynamic software model of the physical plant or system based on real-time continuous calibration of the model. The final intention is to help on digital transformation water sector, mainly focusing in the digital twin representation for water, taking into account the facilities that the FIWARE components of the FIWARE generic enabler can provide in the integration with the IPANET simulation tool. To provide this integration, the first topic that we have to tackle is the modelation of the water network management, like was presented in the previous previous presentation by Alberto and Juanjo. We need to cover all the data to a standard format in order to be in one way shareable to any other kind of integration solution, and also managed by the FIWARE context broker. So new water network management data model can store all the data that is needed to provide those simulations and needed to generate this IPANET model for the water distribution system. Those models include any kind of junctions, tanks, reservoir, pipes, valves, pumps, so on and so forth. For example, I move to the next slide, in which we have a typical network distribution, in which we have a reservoir, a pump, a junction, several pipes, tank, so on and so forth. So the main purpose of this data model representation is to link each of the components of this water network distribution using linked data and provide the corresponding value of the attributes using a standard format of measurement and so on. The next topic, the next slide is I introduce my colleague Chris to follow in the introduction of the integration of IPANET and FIWARE.
Yeah, hello. So I was just going to briefly outline how we can actually integrate IPANET with FIWARE using this data model. So IPANET models are conventionally defined with a text-based input file, which is obviously specific to IPANET. So we need to convert this according to the new data model we've developed. So IPANET has a toolkit that we can use, so that can help with this. So using the IPANET toolkit, we can generate a set of JSON content for each of the network components. So that's in the format defined by the new water distribution network data model. So then we want to store the network model we've generated using FIWARE, so we can push it to a FIWARE context broker. So then that should hopefully just be a one-off process, taking our IPANET input file and making it available from the context broker. So it's sitting there for whenever we want to access it and use it for simulations. Next slide. So while this model's sat in the context broker, we might have other sources of information going in as well. Could be any network modifications, for example, if a pipe is replaced or something, that information could be sent to the context broker to update the model. You might also have sensor data from various sources going in as well. And again, that could update the model without us having to go back to the original IPANET input file. So when it comes to actually using this to run some simulations, we need to retrieve all this information from the context broker. So that's going to give us another set of JSON data, which IPANET can't use directly, but again, we can use the IPANET toolkit to generate what is called an IPANET project, which we can then use for various different purposes. So we might want to just extract some static network data from that, and we could visualize the network. We could run simulations based on the current state of the network, so as we've retrieved it from a context broker. We might want to do some more interesting things. We might want to evaluate different interventions, so we could try applying different changes to the network. So for example, closing valves to see what happens. For example, we could also model different scenarios, whether that's based on forecast conditions, we want to see what might happen, or you might look at historical scenarios, So you could use some other data from a context broker for that. For example, if we've got some historical demand data, we might want to retrieve that and model it, and possibly try that out of different interventions. Next slide. So this is still an area of development. So one of our current developments we're working on is better defining the simulations. So at the moment we're storing all the physical network data, but we also want to store additional information that allows us to define how we're running simulations of the network. So this is important if we want to be able to repeat anything, and if we want to just know how any of our results were generated. Next slide. So to do this, we're actually extending the data model, creating a new simulation entity, which can capture lots of additional information. So for example, what network components we're actually using, because obviously we could have lots of different networks stored in the context broker, or we might just want to simulate a small part of a network. So that information is available. Then we can specify sort of what simulation options we're using. So that could be like what duration we're simulating, what time steps we're using, and so on. And then if we're applying modifications to the network, we can store that information, or any rules or controls we're interested in applying. Again, we can store all the different ones we're using. And then lastly, obviously some sort of description. Next slide. And then, so as I said, this is still a work in progress. There's still developments going on here. So in terms of what's coming next, there's further work to do on implementing this simulation entity. Also need to think about what we do with the results from a simulation. So we might want to store those using FIWARE as well, so they're accessible at a later date. And then the most interesting aspect of this, really, to make it get the most use from it, is integrating with the sources of real-time data. So whether that's, for example, you've got tank levels in the network, or you might have demand data, or various other sources. So there's ongoing developments on that, on how we can update the Ethernet model with the real-time data. And last but not least, obviously demonstrating this with some case studies. And we've got a few different projects doing this at the moment. So we've got work going on in FIWARE for water, Aqua3S, and also I'm going to be using this in a Lotus project as well. So thank you.
Thank you very much for that session, where it is a clear demonstration of how FIWARE works with academia like University of Exeter, as well as working with EPANET to advance the collaboration in the open source mindset, which is exactly the model for FIWARE. So as the moderator for today's session, I have some special privileges to tweak the agenda a little. And I'm going to use that privilege to extend a very warm welcome to a very special guest today. We have with us today Mr. Sotrios Kanellopoulos from the European Commission. We are honored to have you here, sir. So if you could please take a few minutes just to share your thoughts. First of all, let me welcome you again on behalf of FIWARE. We would much appreciate your thoughts on this, and then I would also request the audience to chat any questions that you have for Mr. Kanellopoulos. We will see how we can, tweak the agenda a little to accommodate Mr. Kanellopoulos' schedule. Please go ahead.
Well, okay. Well, thank you for the warm welcome. Probably it will be very short. Thank you for the presentations. I've been following them with interest. For those who know me well, I myself have an IT background, a data background as of training. Before jumping the commission, I was working on designing systems and not in water, but well, enterprise systems, let's say. but I'm not going to comment on the technology per se, because I come from an era when we had to build context brokers with our own means, and they were not there available. So life is becoming a little bit easier now with all these tools. I just want to focus perhaps to give you some information, or let's say feedback on looking from the broader picture, what that has to do with the research and innovation agenda overall. So 3 points. The first point, I saw presentations regarding the value proposition for the water sector itself. I think this is great, and the Commission has been funding proposals and topics on the matter since a long time ago, and will continue to do so. The second that has been mentioned is the smart city concept and the research innovation agenda around that. Water, at least at policy level, is not on the paper of this agenda. I mean, if you look at high-level policy documents, you see energy, you see transport, mobility, health, but sometimes water is not so much highlighted. I think now it's a good momentum to change that, and at personal level, I'm trying that with the help from DG Connect and of course other stakeholders, to make water more visible on the paper policy-wise, because in practice, water is part of smart city, and FIWARE makes it much easier to become more integrated in the smart city concept. And the last part I would like to draw your attention was not mentioned so far. Perhaps I can bring it on the table, and it is this data single market for data that the European Commission has in its agenda for the next years. Well, I cannot describe that in 2 minutes. It's a quite ambitious and complicated topic, but all I can say for the moment is that we can start considering how water and water data, and water sector has a long tradition of collecting data, of course, and now this is being intensified. But how can data from the water sector can combined with data from other sectors can add value? We've seen examples for the COVID for COVID pandemic and the dispersion of cases of contractions of the virus in the population, combining data from sewages and data from census data, GIS, cadastral data, or health data. We've seen applications like that. Recently, somebody from transport called me and said, listen, there was a big impact on transportation of inland water just because of the heat waves and the lack of scarcity of water in mainland rivers, inland rivers. So it was a big impact of billions of euros. So transport and water can play a role, and of course water and energy. We have so many examples, and I think this, together with the data single market agenda of the Commission, can make the digital water agenda stronger, as long as we identify use cases with high value proposition. And this is my message to you. I think that the momentum is good to start thinking in this context. How can all these data that you collect with the help of FIWARE and the interoperability capabilities that FIWARE gives can be combined with smart city data and give a high value proposition, such as the ones that I mentioned, but of course think out of the box to come up with others. And I'm happy to hear from you about those things, and I'm happy to promote those to my colleagues in the research innovation agenda DGs, and in general the research innovation agenda owners. I'll stop here. I hope I didn't took too long, and I hope happy to provide to answers to your questions or other inquiries. Thank you very much for the time.
Thank you. So there is one question that came up earlier that I do want to bring up. I think you have answered it, but it is more technology focused. It came from Stefan. It's about, the projects they most often focus on monitoring and diagnosis and control of installations. Now, the situation is different for asset management, which is not given as much focus, but it is very connected to new technologies, digital twin, artificial intelligence, and so on. So the question is, can that be under the spotlights of the European Commission? I would actually make it a more generic question. Can you comment on the flexibility we have in adopting, the calls from the European Commission? Is it very strict? Are the boundaries very strict, or is there some opening for, expanding the initial intent of the European Commission?
Those who know me know that I work for the ICT for Water cluster as a contact point from the EASME, from the European Commission. At the ICT for Water cluster, we like to consider ourselves as a think tank. Okay, perhaps that's too much, but well, as a community at least of people that work on these subjects, and any ideas that come, I know for sure that the Commission is willing to hear. Because the cluster's voice I know is quite heard and appreciated in the agenda owners of research and innovation in the Commission. Well, there is flexibility. You know that the Commission has its own timelines when it comes to work programs. The work programs for Horizon Europe are for the first programming period are quite advanced. There might be still time to influence that, and in order to do so, the three messages that I presented before, I think, can be helpful. I mean, we have the three levels. Yes, at water level alone, we can continue, but well, the Commission has already invested a lot in that, and I think that the results of that we can see in some of these presentations today, if I'm allowed to say that. But then I think now, if we want to look into the future, we need to see more integration with other sectors. We need to think of circular economy. We need to think of data markets. Despite the fact that, okay, this doesn't come as a contradiction with GDPR. That's the complexity that comes with the data market, is the fact that in spite of the GDPR, in spite of the constraints that we have in place, in spite of the confidentiality of data, in spite of the commercial importance of data, still the Commission wants to have a complicated governance system to allow exchange of these data because they add value. And then that's another thing for the water sector. That can contribute to, and then if there are ideas on that, I know that there will be a lot of people from the Commission that will be happy to hear and promote.
Thank you so much. We started the session with Robert, ending on a message of the future is bright. With your participation today, the future looks brighter. So thank you so much for jumping in and sharing your thoughts.
Thank you.
We will now move on, continue actually with the University of Exeter, where we have Kate Baker, Research Fellow, the Center for Water Systems, and Ben Ward from Southwest Water. Ben is a drinking water asset manager, and they're going to be talking about FIWARE for water. You might remember that was one of the projects that Professor Dragan Savic outlined in his session. And they're going to be talking about a global issue, but we need local solutions. So please take it away, Kate and Ben.
Hi there. Hello. Can you all hear me? Yes. I'm going to turn on my video as well, although I think it's a tiny icon, so you won't really be able to see me. But hello, I'm Dr. Kate Baker, and I'm presenting this here with Dr. Ben Ward. I'm a research fellow at the University of Exeter, and Ben is at Southwest Water. And we're going to be talking about a case study that's part of the FIWARE for Water project. And it's a collaboration between the university, Southwest Water, and the community of Great Torrington, including the Council of Great Torrington. And findings from this project are also feeding into the UN World Water Quality Alliance. So you might be thinking, oh, how do we go to the next slide? There we go, slide 2. So you might be thinking, where is Great Torrington? So on the map here on the left, you can see where Great Torrington is. It's showed as demo case study 4. So Great Torrington is a small market town in the middle of Devon, and it is a not a large population, quite a small population. And we, South West Water, are putting in some smart water meters into this town. And so the aim of this project is to work with the customers and find out how these smart water sensors can be used to help them reduce the amount of water that they're using. And so often a question we get from the community is, why is this important? I don't think the UK is renowned for having water shortages, especially compared to other European countries. But as with the climate crisis happening, we know that weather is changing. And in the UK, we're going to be, well, we've started to have water shortages in many years, but this is going to increase. And we're going to, in 25 years, we're going to have quite severe water shortages. So this project is trying to keep ahead of the game, as it were. And we're working with the community to sort of raise awareness of the amount of water that they use. And so I'm going to hand over to Ben now, who's going to talk through the app and the smart water sensors that they're putting into the town. And then we'll come back to me and we'll talk about how we're engaging the community. So over to you, Ben.
Thank you, Kate. Hopefully you can hear me all okay. I'm going to assume that's a yes. Perfect. Yeah. Yeah, thank you for setting the context, Kate, and for allowing me to speak today. I'm going to give you just a few slides, a bit more background, as it were, around the project that we're working on as part of the FIWARE for Water project, and also as part of one of our business plan commitments that we've made to our customers. So South West Water supplies water and sewerage to about a population of 1.8 million people, and we supply Devon and Cornwall predominantly. So it's the southwest coast of the UK is our supply area. And like the other 16 or 17 water utilities in the UK, every 5 years we submit a business plan to our regulator. And in that business plan, we outline our commitments to our customers, and we outline largely what our investments will be over that 5-year period. And part of that, we made a customer promise that we would offer all unmetered customers a dual bill. And that doesn't mean to say customers need to pay twice for their water. It is actually quite the opposite, in the fact that we will offer them 2 bills and they get to choose which bill they want to pay, and normally that would be the lowest bill. So the reason for providing 2 bills is firstly because these customers are unmeasured, so they have standard charges which are normally set based on their historic property values. And what we want to do is we want to move these customers onto a meter, and we want to do that for a number of reasons. Firstly, because we believe and we know most of our customers save by being on metered charges, so it's good for them. Secondly, and what Kate talked about at the start, is that by being on a meter, customers are more aware of their water consumption. They are more aware of how they're using water around the house, and ultimately, customers who are on a meter actually use less water for their equivalent household size. So it helps the environment, it helps the customer, and it also helps us as a utility, because it will hopefully help us get to achieve a number of our performance commitments, which I've bullet pointed down the bottom of the slide deck here. So we believe this project is a bit of a win-win for us, the customer, and the environment. Next slide, please, Kate.
Yeah.
So where we are currently then is we're currently ramping up to deliver this project, and we're doing it so with a pilot project in the area of Great Torrington, which Kate has shown. And we picked this as a rural town because it represents a lot of our towns in and around Devon and Cornwall. We don't have too many large cities, and we thought it would be more of a challenge to try and deliver a technology-based solution that's all about communications and data transmission in a location that is much more rural and more difficult. So we installed and we enrolled 100 customers onto our dual billing project, and we installed 100 smart meters at the back end of last year. And since that installation, we've been picking up daily consumption data from these smart water meters. And we've been analysing that in a platform that you can see there, which is Power BI. So it's an analytical platform, and it's working quite well for us as a utility. We are getting the daily information back from those meters. We can rank customers by their consumption, and we can look at different leak alarms and things like that. But at the moment, it's a little bit automated, a little bit manual, a little bit clunky, and we want to use the FIWARE platform as a way of automating that, and hopefully to get a bit more additional insight as well around further analytics of the water consumption and the leak alarms. Next slide, please, Kate. So what we're doing is, as I said, we're providing a dual bill, and we do that just as one, but we do it as a comparison. So on that bill, you'll see what the normal meter charge would be for that customer. We use their consumption over the period of time to make a bill estimate for the year, so that the customer could see what their bill might be like if they, based on their current water consumption. And then obviously we show the savings. And by and large, that works quite well. And we can automate that in terms of the letter generation. And it works well where customers save. And I'm quite pleased to say that 2/3 of customers, approximately, are saving by being on this pilot. And some of those have been quite significant, £900 in one instance. But where it doesn't work so well, and where we really need the support of technology and a platform like FIWARE, is where the customers aren't saving. Because we have to do a lot more analysis, and we have to work with the customer to understand their consumption, why it might be high. Is it a leak? Have they just left a tap on for a period of time? Or are they genuinely using more than we would envisage? And we work with them to try and reduce that consumption. And that involves us going back into the dashboard that I showed you, doing a lot of analysis. And really, we want FIWARE to help or empower the customer to do that type of analysis themselves. So a bit of a self-help, self-serve type system. We don't necessarily see the need for the customer to be coming back to us all the time to understand their own water consumption. Last slide, I think, for me, Kate. So this is just a couple of mock-ups of what the app might look like, just to show you our thought process. We want to keep it simple, we want to keep it engaging, and then once we've done that, we will look to make it more advanced, where customers can potentially set their own limits and receive notifications if they exceed certain limits, and possibly also look at some sort of community engagement piece where we might run competitions for water consumption reduction and things like that. So a lot of potential, we think.
Great, thanks, Ben. So as I think you'd all agree, it's really exciting technology and a really great opportunity for the community of Great Torrington. But I think what we also know is that you can't just bring in technology without bringing the community along within the journey. There's been so many stories in the past when you have the most fancy technology that's brought in, but people are not engaged in the process, and they either don't use it or sort of actively don't want to use it. So I think this is a nice quote to sort of highlight that. And so how are we going to include the Great Torrington Council and the community? So we are co-designing the technology with the council, and we approached them at the beginning of this project to ask if the council want to be involved and if their community want to be involved. And there are two main reasons why we want to do this. It's because we want to investigate the benefits of the sort of digital applications for communities. And secondly, we need to make sure that the effort that the researchers at the University of Exeter and South West Water are putting into the app, you know, it will then be used by the community. And so how are we doing this? So we attended the Great Torrington Town Council have a monthly meeting, and we attended that in July, and we presented the FIWARE for Water project to them. And they were really excited about the project, and they were saying that there are many community groups that had started in the town that were very interested in sustainability and how they can make small sort of individual actions to help with the climate crisis and just be more sustainable. And so the council agreed that they wanted to get involved, and they said that they would put us in contact with local community groups. We've been aligned with a a councillor who is in charge of the sort of environmental issues of the town, and we're now working with him to plan sessions over the next few months, probably until December or January, to work with the community to get their feedback on the app. But also we're wanting to give them an opportunity to develop a local policy that they will then be collectively responsible for, ensuring that that policy actually leads to practical action. So it's asking the community what they are interested about or what they're concerned about, and flipping that into making that into practical action, and working collectively with the council and the community. And this will then also link in with the app that South West Water are making. So we're at the beginning of this journey. We don't have any data and information to feedback, because we're just planning for the first meeting now. But hopefully early next year, we'll be able to let you all know how we get on. But if you do have any questions, then at this point, then do let us know. Otherwise, thank you very much.
It is not just enough to have technology and systems, people have to use them. What a great message there, Dr. Baker and Dr. Watt. Thank you for kicking off the second half of today's session, which is about case studies. What both of you spoke to was the first of 5 case studies that will be showcased today. We move on to the next one, which is about FIWARE and the NAIADES Smart Water Platform. We have Dr. Yoonsuk Yuna Kim from UDG Alliance with us today. So Dr. Kim, please go ahead.
Thank you. Yes, we'll talk about the FIWARE in NAIADES Smart Water Platform. NAIADES is one of the synergy group projects that what Professor Savic mentioned. So I'm from the UDG Alliance on the expertising on the FIWARE IoT platform. Just would like to briefly introduce the NAIADES. The NAIADES is working for the smart water management for sustainable development goals. That we gathered 18 consortium partners across Europe to work for 3 European cities. One in South Europe, in Alicante in Spain, and then Central Europe, Garut, Switzerland, and Eastern Europe, Braila, Romania. These 3 cities have very different requirements on their water management, so that I would like not to go to much details on the technical side, but I would like to focusing on the user requirements, because that's the first step to understand what kind of technologies you are applying for. So that I will go on each city's requirements. First, at Alicante, Spain, this city doesn't have the local water source. They have to transfer water from the 170 kilometer away of the repository. So and then also have a very unique situation that this nice Mediterranean coastal city has a very big population variation between summer and winter. So almost 200K. So that they need to optimize the water demand in the right season. And then the other one is that they see that they are in the coastal city. We visited their very nice 2 wastewater treatment plants, and they try to reuse the water, and then quite actually big amount of water is reused. But the problem is that they have saline water intrusion, so that their estimated total economic cost is around €1 million per year for that. So what the city wants us to handle is the detection of the saline intrusion spot, and then could work on this. And of course, for this, they have a quite limited water production part, so they want to have a customer awareness campaign, and so that the project will also help on that. So eventually, we know that the only giving some awareness to the users that you could actually have a quite big impact on the usage of the water and energy and so on. That's the problem of the Alicante, and the Braila in Romania has quite also different requirements on this. This area doesn't have much rain, but actually they have a very good water source, the Danube River. So they do not have any problem on the water production, unlikely the Alicante. But their biggest problem is the water leaks in their water distribution network. So in their measurement in 2018, they have 41% of loss due to the pipe leak. So that they want to drastically reduce this amount of leakage. So that during the project time, they will install the sensors to measure the pressures and so on. Because currently, it's on actually the manually that they only rely on the reports from the dispatchers. So there is something happens and all of a sudden unusual water consumption and so on. So that we want to make automate and then make a real-time monitoring. And then of course also for these connecting the region, they want to also have some forecast system for the water consumption and the demand. Rather the short term, because suddenly leak happens and then the water consumption, amount of water consumption would be quite large, so that it's related to this. The city of Garud in Switzerland has a pretty different requirements on the water management. While these two cities, Alicante and Braila, we are directly working with the public water utility the organizations, so that it's more related to water networks. But here, the Garud doesn't have a direct control on the water utility networks. Their water system is fully just controlled by the province level, so that there is a public utility companies it's directly working with the province level, so that the city is just as one of the consumer of this water. And so that this part of the work that we are working directly with the city council officers, so that what they are bringing to us is the city has a city gardens across the city. They have a flower box and also city gardens that they give away to the citizens with the free. So any citizens can come and plant and grow the vegetables or flowers and so on. But the city is responsible for watering, and that the city officers use some water truck, and then every twice a week or the fixed schedule they are watering, so that they want to have a enhance this kind of inefficient water usage by them, and also want to reduce the labor consumption. Because at the moment they do not. It's really up to the city the city staff that they check the weather if we should go or not. But just normally they just go the fixed schedule. So if we combine the some sort of the smart system that we could make it this work much more efficient. And the other one is that if you visit Switzerland, you will know that almost every cities we have water fountains that the citizens can directly drink the water from the fountains, and then some big fountains. Actually, in the summertime, that's citizens, actually small kids, go jump into the fountain water, also dogs, and then they swim and play. So so that the cities who is responsible for the water quality is caring about the public health on this. So when the water quality is a little bit bad, and then it's really directly impacted a lot of citizens. So they do manually every day. They check the pH, bacteria, and chlorine, so that they put it to the note and then just send to the for the exam and like that way. So one of these most popular fountains actually consumed 2 million liters of the water per year. So they want to make it efficient when they actually should change the water, not just the regularly, but just they want to monitor the water quality every day in a fresh, real-time data, and they also want to predict if the weather changes, and then there are many citizens go into and so on. Then they want to they can predict that they want to see the prediction that how much of the bacterium chlorine level can be changed and so on. So these requirements is also quite unique. So as I said, that these 3 cities brought quite different requirements to us, and so that a lot of experts gathered together before we just launched the project, so that we discussed the issues and how we could solve. Yes, so that we put the technical puzzles together. On the city side, that we would need the water infra data, and then SCADA data integration, and then also open data that such as weather. So we need to integrate, and then we need to install the new sensors on the depends on the use cases and different sensors, so that we brought the experts on this side of the manufacturer sensor station manufacturer and so on. And of course, many things like many of other projects are doing, that we gathered a lot of technical experts on we can put into the cloud, because we have 3 very big different cities, and it's not only for 3 cities. The goal is to support this kind of city, the systems if we build, and then for the other European cities as well. So things we put it into cloud. And inside the cloud, we put AI and then decision support system, and then user awareness the systems, so that as you saw the requirements, we put the water demand prediction, water consumption prediction, and then report real-time monitoring and failure and leakages, and with the urban water models and water quality forecast and weather prediction is directly related to many of other use cases, and consumer confidence water treatment suggestions to provide such things. And user side, of course, that they want to have a user-friendly visualized applications, and real-time monitoring and prediction service, and then certain things happens, they should get the alarm service for the critical events. And of course, also the consumer awareness information. So that we collected the technical partners, and they're working together with these CD staffs. And then there is another problem. So how we can put these pieces are together. We know that the different cities have a different data formats and types, and then also the AI systems use a different way of outputs, and then also and then want to provide the holistic solutions. Then we need something more than this piece of the technical puzzles. Yes, so that we need the data interoperability, basically, so that all the different 3 type of the cities, and then beyond these 3 cities, we need the common data models to change to all the different types to bring to the clouds and to the end users. So reusability is very important, so that we need a standardized open APIs. That's what FIWARE is providing. So that already in the previous presentations that we already heard the context management, and then here on top of that, also with the different users we have to support, so that the identity management and access control are all from the FIWARE solutions, so that we are now building to link and bridging all these technical aspects and together. Yes, that's the field work that we are now installing the sensors. Next. Yeah, this is our prototype. So Naya, this is now a little bit more than 1 year, so that we are now building the applications for all the required city needs, and then try to provide all the visualization, and also like a mobile version of the user interfaces we are providing. Yes, and then also different type of the information they could check that from dashboard and things. Next, that's the end of the presentation. So that I just quickly overviewed of the what's the user requirements and the what we are building and the why we think we take the FIWARE. What's the major the reason that the power is from the FIWARE. So that I'm happy to discuss further. Please feel free to email me if you have any further questions, and then I skipped all the technical parts, and then if you have more information to share or discuss, then feel free to contact me. Thank you.
Thank you so much, Dr. Kim. So we are beginning to see a story here. We heard from Dr. Watt and Dr. Baker that people have to use the systems and the technologies. We heard from Dr. Kim about 3 different cities where the technologies are being applied. That takes us to innovation. So how can we innovate technologies for safety and security? So let's welcome Dr. Tassos Karakostas from the Center for Research and Technology, Hellas, who's going to talk to us about innovative technologies for the safety and security in existing water networks. Please take it away, Dr. Karakostas.
Thank you very much. I'm going to talk about our project Aqua 3S. The 3 S are for safety, security, and standardization. The Aqua 3S project is actually a security project. It was under the umbrella of DRS 3 2 years ago. Right now, we are in the first year of the project, and I'm the coordinator of the project, and I'm going to present you how a complex, innovative project like this needs FIWARE. Chris from Exeter and of course Frédéric from Suez described previously a lot of details about how our project contributes and is related to FIWARE. But now I'm going to present why a project like this needs FIWARE. So Aqua 3S tries to fill the gap that although we have a lot of new innovative technologies to support water authorities and water utilities regarding safety and security of drinking water, we need new methods on how to integrate these solutions to existing infrastructures. So Aqua 3S combines these novel technologies and standardize the way that these technologies can be integrated into the existing networks. So we have several technologies from sensors, IoT, semantic reasoning, decision support systems, situational awareness methods, and we are combining some new sensors that are developed in the project together with some more new technologies like, for example, image and video analysis from UAVs, image analysis, analysis of satellite images in order to see incidents of pollution in rivers or lakes that are bringing water to the cities. So the data that we are using in Aqua 3S is either from the existing sensor networks that the authorities already have, the existing infrastructure, or new sensors that we are developing, and also all the other input from the solutions for the UAVs, the social media that I will explain later, and how we can provide this decision support system to the authorities through Aqua 3S. Here you can see an overall picture, an overall concept picture about the project. So we have the input from the river, we have sensors in river, sea, and we have the UAVs to detect pollutions. And at the same time, we use different type of sensors and existing end-of-the-shelf sensors, and all this multimodal information is aggregated, and through specific visualizations, we try to support, even in real time, almost real time, the water authorities. Here you can see the main objectives of the project, and at the moment we are in the first year. We have ready the first prototype of the Aqua 3S platform. And at the bottom of this page, of this slide, you can see the different technologies that we are using. And at the upper level, you can see how we are engaging both the water authorities and also the citizens' input in order to have these needed strategies and methods to integrate the solutions. Here is how the standardization needs to cover all the aspects, from the technologies that already exist, from new technologies, the integration of these technologies, the new platforms that we need to develop, and the standardization and the policy should cover at the end all of these objectives. Aqua 3S as a DRS security project uses a lot the pilots in order to test, evaluate the solution, and to develop the standards. So the idea is that we have several pilots we have strong end users in the consortium, like Suez that I mentioned, with Aqua from Brussels. And we have several pilots that we test different levels of maturity of the solution. And now the important is that we are ready to have the first pilot in order to test the first prototype, and this will be also part of the standardization development procedure. So the evaluation has to do with the system, the prototype, and the final system evaluation. User-oriented evaluation, we have done with our end users a lot of work here, and the results has to do with a final system that will support these 6 pilots, different modules, and operational approaches and guidelines together with the standardization of the solution. As you can see, the impact we target, of course, in the security of people, in the emergency working routines in the society. As you can see, we have several different components. We have more than 10, almost 11, 12 different key results, technological innovations and key results. So we need somehow to integrate, combine these solutions. That's why we are in collaboration with FIWARE and the other projects to see how we can create the needed data models, how we can combine the solutions, how we can combine the technology. So that's why FIWARE proved to be the most efficient way to work in such a complex system. At the same time, the Aqua 3S is dealing a lot with the policy framework. It's a security project, but we have to deal also with policy. Now we have under a very strong review that we have done the last months. We know the relevant policy requirements. We have identified the needed gaps, and now we are in the process to develop a new outline of new policy recommendations and a specific white paper for the policymakers. At the same time, we are working on the standardization of the project, as you can imagine, because this is the goal of the project, in order to formulate some CWA strategies to identify the gaps of the existing standards. We are talking about this, except from the safety, which is covered a lot. The security of the drinking water is not covered a lot in the standard, so we are working on it. So we are in collaboration with specific SEN, and we are ready to create, organize 2 relevant workshops for the CWAs. And finally, the goal is at the end of the project, together with the final software solution that the authorities can use either as modules, either as a whole solution. The goal is to have a specific report to provide guidance for the future application of the solution, together with the initial CWAs that we are planning to do. This is our consortium. As you can see, 23 partners, excellent end users, excellent technological partners. The project is rather ambitious. So if you have any questions, if you would like to know more about Aqua 3S, you can send an email and I will provide more details. Thank you very much.
Thank you, Dr. Karakostas, for a very crisp session on time. So with that, we move on to Dr. Adriano Mancini from Università Politecnica del Marche. And that's going to be the fourth case study on digital Water.City, early warning system and matchmaking platform for safe and optimized integration of wastewater treatment and agriculture irrigation. Dr. Mancini, please go ahead.
Yeah, thank you for the introduction. So in this presentation, we will focus mainly on the digital solution that we provide inside the DWC project, Water.City, and we focus on the wastewater, especially for the irrigation in agriculture. So we speak about the reuse of water. So just a few words regarding the DWC project. The DWC projects is a complex interaction of different kind of partners that try to demonstrate 15 digital solutions. So we have a lot of solutions that focus on different topics, and they want to reuse as much as possible and develop new technologies in the field of artificial intelligence, augmented reality, cloud computing that is really connected to the FIWARE that we are discussing today as decision support system that we will discuss in the next slides. If you want to have more details regarding the digital solution that we have in the DWC project, please check on the website where we have a lot of details regarding the digital solution. In particular, the DWC project will focus on peri-urban areas. So this is quite interesting because in peri-urban areas, we have mixed scenario where we have citizens, but we have also agriculture farms, or dairy farms, or different kind of stakeholders. So in particular, we focus on 5 cities, big cities in Europe, as Berlin, Copenhagen, Milan, Paris, and Sofia. And in particular, for the smart irrigation, we focus on the Milan test case. So looking maybe the digital solution inside the Milan test case, first of all, we focus on the early warning. So this is quite important because if we want to reuse water for agriculture, then we have to be sure that the quality of the water is compliant with the regulations. So for this purpose, there is a strong coordination of different partners that are working to provide an early warning system that is based on methodological approaches and also on data coming from the plant in order to establish the warning regarding the functionality of the wastewater treatment plant. In particular, the system is able to fetch data from the plant, to fetch data from the lab analysis, for example, and to establish, where it's possible, a correlation between the data and some variables that could be measured in order to create virtual sensors. So the idea that we want to demonstrate in the project, in particular, we want to integrate the FIWARE, is to try to integrate the early warning system inside the FIWARE ecosystem. So we will have a custom instance of the FIWARE architecture for this project, in particular for the Milan test case, and the early warning system will be one of the components. So the second solution that we want to demonstrate inside the reuse of water is the footprint. So what we want to do is to try to integrate the data coming from the plant to establish in a quasi real time, which is the carbon footprint of the plant. This is important because, as we will see in the next slides, we have different kind of stakeholders that could be interested on the understanding of what is happening in the peri-urban area. So, which is the impact of the plant, which is the impact of the water that we want to reuse. So this is a really important part of the digital solution, and this is just maybe to focus more on the FIWARE. There is we are moving the first steps to integrate the control room of the utility where we have the data into the FIWARE architecture that we plan to have. So in particular, we want to establish a connection with the data by using a classical mechanism of Industry 4.0 as the MQTT and so on, just to translate the messages, the data that is coming out from the control room into the data models that today have been presented and mentioned by the FIWARE Foundation. And in particular, we are working on the data models just to reuse as much as possible what is existing and try to propose in the future maybe some customization regarding the data models. Of course, this is the basic architecture, but the most important part is that it's possible to ingest data in real time from the plant to the FIWARE ecosystem. And for the agriculture, it's really important to match which is the real demand from the end users with the capability production of the plant. So what we want to develop is a matching tool that want to match the quantity that is demanded by the stakeholders, in particular from the farmers, with the capability that the plant has. So not only the quantity of the water, but we want also to find the match with the quality. So quality and quantity are the two variables that will be used to find the best match with the requirements for the user and the capability from the plant. In particular, the matching tool has different kind of stakeholders. I think that we have no time to go in detail regarding this, but as you can see in the tool and in the FIWARE ecosystem that I mentioned before, we have different kind of stakeholders that could view or put data with different kind of let me say roles. In particular, the farmers have strong impact on the quantity of water that is demanded to the plant because the irrigation method plays a key role. So the configuration of crops and irrigation methods around the plant has a strong impact on the reclamation manager that is responsible to define the treatment options of the operation in order to optimize the plant. And of course, this has a strong impact for the water utility. And of course, the water utility has strong impact on the citizens and urban users. So different kind of stakeholders that could fetch and view different kind of data that are in any case ingested by the plant. So the idea is to first take the data from the plant, ingest into the FIWARE, and then process the data in order to generate a nice dashboard, nice KPIs that could be used for different users. What is really interesting that we will demonstrate is the integration of different sensors. So metastation, salt sensor, active UV has been mentioned in the previous project, because we know that this kind of sensor could be a trigger for some water stress. So just to improve the estimation of the quantity that is needed in that specific time in that specific area. So the idea is to close the loop where it's possible, of course, and the matchmaking tool will be maybe a decision support system for the reclamation manager that should be able to understand which is the real needs for the end user. What we change in the architecture, of course, is the ingestion of other kind of data. So X sensor, satellites, and UAV. This is quite straightforward in some case because we can reuse the same component that we use for the control room, of course, translating messages in a different domain. But what is interesting that in this domain, there is a strong requirement to define the new data models that are able to map the variables that we can measure by using, for example, sensors deployed on the ground. That is a great challenge to fuse together the FIWARE initiative with the water initiative and the agriculture initiative, because they are so strongly connected in agriculture that in our project we want to try to define this kind of integration. And we have just 2 words regarding the development plan. So we are moving the first steps. So we are in the POC phase, but in the next weeks we will perform some nice tests, integration tests between the control room and the FIWARE instance that we have. And the next step will be to the development of the microservice to implement the algorithm that we have for early warning system, carbon footprint, and for the matchmaking tool. So thank you so much for your attention. We just focused on the FIWARE because this is really interesting, and the opportunity to use this kind of ecosystem for us is something of a really interesting. And thank you for your attention.
Thank you, Dr. Mancini, for a very well-timed session. We now move on to our last but not least case study on SCOREwater. It calls out the synergy of an open platform and active citizen engagement. Arjen Hof Director of Savic and member of the SCOREwater Consortium, will be sharing his thoughts. Arjen, please go ahead.
So everyone is still there. I can imagine you all get a little bit tired after hearing all these sessions. So let's see if we can add some interesting viewpoints other than already mentioned. I'm involved in the SCOREwater project with a lot of other people that you can see over here. I will mainly focus on the 3 case studies from Barcelona, Göteborg and Amersfoort in the Netherlands, and that we are implementing at this moment. And I will also mention something about the marketplace that we are developing at this moment. So you can see the list of participants over here, but you can see the presentation later on. This is the platform, and you've seen pictures for platforms during this afternoon, many more. And we are also complying to the FIWARE standards, not only the software components, but also the data models and the open APIs. And interesting to mention, Sartorius was in the meeting earlier on, that we are involved in another European project as well, near the city of Amersfoort with Utrecht, that is about energy transition. And there's a lot of exchange of knowledge between these projects because developments in the water sector are influenced by things about energy as well. So data about energy consumption, air quality, water management are very interesting to reuse in this project too. So as you can see over here, at the bottom are all the devices and sources that we use, and in the middle the platform. And interesting to mention is that one of the key areas that we focus on in this project is developing a data market. And a data market is more than just providing the open data, but it's also about creating new business models for creating innovative new applications. And providing the data from the several partners, not only government agencies, but also SMEs, businesses and research institutes. It is interesting to focus on the access rights and the ownership of the data that can be used by others. So for example, if we have models and algorithms and data that is provided by a commercial party, then part of it can be provided as open source, open data, and part of it has a licensed version of the data available. So within the platform, we also use these FIWARE components and focus on API management to make the different APIs available for reuse by others with different subscription models attached to it. So that's something I will come back later on as well. And the other part that is very important in this project that I will focus on in the case studies is the citizen engagement. It was mentioned before, technology is an enabler and it's interesting, but it's all about involvement and engagement of citizens in the project as well. So first, a bit about the Barcelona case. Let me see. And in Barcelona, we are focusing in the SCOREwater project on different topics. And in Barcelona, there's a lot of interest in the sewerage system. And what they are basically trying to do is to correlate, and it's one of the projects, the behavior with water quality. And they have defined three different neighborhoods in Barcelona with different demographics and population. And they are trying to find out whether there is a relationship between the quality of the water in the sewerage system and the usage of all kinds of medicines and other things that are being used by people in Barcelona. And they use a lot of sensors to measure that, and it's quite relevant in this COVID area as well. If you can detect pollutants and medicines and drugs and other things as well. And that is what is done in the Barcelona case. And they mine the different data sources, not only the sensor data, but also census data about demographics and other kinds of information. And they use it, also the medical databases that they have access to, all in a secure and anonymized way. They use surveys as well. So the interesting part over here is that by using the FIWARE platform tool, we can have unstructured qualitative data and structured quantitative data combined to get insights in the health status and risk factors in different neighborhoods in Barcelona. So where Barcelona is focusing on the sewerage system in the project and the engagement of people. So they have done the surveys together with the inhabitants of the different neighborhoods, and they have involved them in the development of the census as well. And that's interesting because it's all about creating awareness in these neighborhoods of what is happening and what their effect is of throwing your medicines and other things away. And the keywords in this Barcelona case are, and it's not only the Barcelona case, but it's like identifying all those social enablers in the project by doing surveys, by investigating census data. They use and test the different census and ICT tools, engage the citizens in the project, and creating a marketplace with valuable data, insights, and algorithms that can be used by others to create new solutions for this water market. In the city of Gothenburg is something completely different, but that's the interesting part of SCOREwater. We are focusing on the whole chain of the water management, less than the drinking water quality. We are doing things like sewerage and climate adaptation and wastewater management. And in Gothenburg, they are building a large new train tunnel underneath the center of the city, and they have to comply with the legal recommendations in this project for construction projects about wastewater. And they have installed several sensors for measuring the water quality in this project and getting the data out of this project into the platform that you have seen before. And this is a different data source that can be used as well. And it can be used for real-time monitoring whether the pollution of this construction site is within the legal boundaries. In the Amersfoort case that I know a little bit more of because I'm involved in this case with other people, we are more focusing on climate adaptation and on citizen engagement in a very large part. And one of the projects that is involved is called Measure Your City. And it is a citizen project over there where people create their own sensors and are educated about how to create those sensors. And all this data is available as open data already. But what is interesting and what is very something to learn about is that the transformation of this open data and making it available in the FIWARE data models and through the NGSI API needs additional transformation and additional work. So together with the people in Amersfoort, we are collecting this information about air quality, water quality, and heavy flooding in the city after heavy rain. And this data is made available now in our platform as a FIWARE NGSI API, while it started as just a citizen science project to collect data about several topics. And now we have the whole chain where people can learn about the quality of their data in this citizen project. What does the data mean and how can we interpret it, this data, and how can we also visualize it in a dashboard. And what you can see on the left is what we are going to do now in Amersfoort is adding a lot of new sensors in the city. And there's a QR code on it that people can scan and get extra information about what data is collected, where they can use the data, which sensors are used, and how the whole platform and process is working in Amersfoort. And in the middle, you can see the big challenge in Amersfoort is what was mentioned before about green infrastructure and climate change. Amersfoort, you won't imagine, but Amersfoort is in the Netherlands on a slope, and we are a flat country, but we have some. We have the Dutch mountains for people who know. But in Amersfoort there are chances of heavy floods and heavy rains that make the street flooded, you see over here. And measuring these kind of things and predicting these kinds of flooding and predicting heat stress in the city is the challenge to do in Amersfoort, and getting the water management system in place too. You can see over here what we have done in this FIWARE project. This is a sensor from the citizen science project that people have created themselves on the left, and what it is measuring, and temperature, humidity, and some other things. And on the right, you can see that we have now transformed this Measure Your City, that's the project name, to our FIWARE platform and make it available through an NGSI API and the transformation. So this is work in progress, and it will be provided as an API in the marketplace so that we have this whole chain operational. Important as well, and it was mentioned in this green infrastructure as well, and just for the information that it's very important that we don't talk only about managing stormwater or other things, it's also about greening our urban areas with other things, because it has a lot of benefits. And one of the benefits that we see over here is that we have done a project in Amersfoort where we have information about all the trees, and all the trees also according to the FIWARE models, and we have tried to adopt and change an existing project coming from the United States, was called Open Tree Map, and see if we can apply the FIWARE API and the FIWARE data models to it to get information from the trees about their eco benefits and their eco things that they contribute. So overall, if you've seen the Barcelona case with the sewerage system, the Gothenburg case with their legal compliance with construction sites, and Amersfoort about climate adaptation, is that we reuse this whole SCOREwater platform based on FIWARE tooling and make it available. It's a cloud platform that we use as well. And basically we focus now getting all the sensor data from Gothenburg, from Barcelona and Amersfoort in it, transform it and put it in a data market with API management on top of it, so that we can also apply billing and metering and get insights in usage of it, and create the developer support on top of it. So we have the sensors in place, we have the use cases and the case stories operational. The data is collected in the platform. We are now applying these API rules on top of it, so that we have a universal data market available in this SCOREwater project.
So there, okay, perfect. I was about to jump in there, Arjen, so thank you so much. Thank you. So that brings us to the end of the case studies. I would now welcome the CEO of FIWARE to share his thoughts to end the session with closing remarks. Please go ahead, Ulrich. We cannot hear you, Ulrich. I think you have to unmute yourself.
It might be better to unmute myself.
Yes,
so you can hear me now. So thank you first of all for this really impressive list of speakers and the content we saw from different areas in the world, making clear that water is a very, very valuable resource already now, and it will become even more valuable in the future. And what we also saw is that water is in the center of the smart development goals of the United Nations. And we are more than convinced that digital solutions will help us to better achieve the smart development goals on a global scale. And this means in the area of water, to turn the focus from managing the supply side to a future water management approach where the demand side is more managed and adopted to the existing sources. So we have to manage limited water supplies efficiently, and this will increase in the future, definitely increase in the future, and therefore we need to put more focus on these activities and open source technologies. And we saw a lot of examples of this combined with open standards for interfaces, for APIs, but also for data models, as very excellently explained by Arjen in the last presentation. They will help to create these solutions. And on the other hand, digitization will be able to reduce the cost for operating and managing these resources. So therefore, IT and digital solutions will support the Digital Water Action Plan from the European Commission, and again, using open standards, using open interfaces will help the community to reduce what we call the vendor lock-in effect. Whether it can be completely avoided, that's of course a question, but definitely by using open standards, open data models, this can be reduced, dramatically reduced. So again, for me, a very impressive session today. Thank you to all the contributors. Thank you to all the participants. And I'd like to hand over now to our Chief Marketing Officer, to Christina, to give us an outlook, what's to be expected next.
Yeah, thank you, Ulrich. Thanks for this wonderful afternoon and the summaries, and also thanks to our great moderator, because you carried us through the whole afternoon with such a great fil rouge that it's really hard to wrap something up, because you did that continuously to keep everybody here up to speed and always very well connected. So very big thank you to you too. This brings me to just adding a few things that you might be interested in to make it a little bit easier to access material that we have for you. As this is not only about what you heard today, but there is even more. So as a great coincidence, or actually a great planning, I have to say also thank you to my team. Just today we launched a white paper. This white paper is a community work. You find already existing solutions around smart cities in there that also include water. And it's really it just got online today and distributed to the press worldwide. So I put the link here into the chat, and please just have a look at it. I think it's extremely interesting there. And it's it also shows what we heard today, that water is not a standalone vertical. It's really linked to so many areas and makes part of smart cities. We also have a climate booklet, by the way. So if you go on our website and type into the search machine climate booklet, you will find lots of off-the-shelf solutions there as well, and some more information about all the water projects where FIWARE is in. And the very, very last thing, so we close in time today, is there is upcoming events. So if you like this event today, then join us for the upcoming ones, and the next is straight tomorrow, which is about the future mobility. And you will hear about lots of areas where the future has already started. We will have a really great book author there and speakers from the European Commission. The event is 80% in German language. This is a big exception. So if you are able to understand German, so join. Otherwise, at least join for the very first speech of the European Commission. That will be nice too. And then from September 21st, we go back to English and have 2 more days about the circular economy and health day, and many more to come. Okay, so this is just the next 3 of them. So in the name of FIWARE and in the name of the marketing team that has arranged for today's Water Day, thank you very much also to all speakers and to our media partners. And if you have questions, please contact us. We're always keen on getting your feedbacks, and promise to send any answer to your questions back in due time. Thanks again. And we are 4:30 almost. And very, very last salut or salut back to our great moderator. Thank you. Nat.
Well, thank you, Christina. And if you can make me presenter, I have a surprise slide. So I noticed a pattern of the number of 3. There were many reasons why the 3 came up. I saw the theme of collaboration, integration, and application. We heard from Dr. Tassos Karakastos on safety, security, standardization. S3 or 3S is the Suez Smart Solutions. Coincidentally, Dr. Kim and Arjen both spoke about 3 different cities in their session. So there is something special about the number of 3. I will leave you with those thoughts. That's all I had.
Thanks, Nat. And then I'll say goodbye and goodbye to everybody. Thank you for your participation and your time and efforts.